I think everything is pretty clear and pretty visible to everyone, right? So, see, in today's class, as I told you just now, we will be learning about viral method or viral equation, in another words, you can say. And this equation on this method can be informing us about simply the relation between scattering angle and the scattering intensity. What does it mean? It means जो कुछ भी आपके electrons इलेक्ट्रॉन डायफ्रैक्शन मेथड है, इस डायफ्रैक्शन मेथड में हम लोगों के ये जो कुछ भी इलेक्ट्रॉन्स होते हैं, इन इलेक्ट्रॉन्स की हेल्प से जो कुछ भी डायफ्रैक्शन होता है, इन इलेक्ट्रॉन्स की हेल्प से जो कुछ भी डायफ्रैक्शन होता है, दैट डायफ्रैक्शन we can observe that diffraction. What we can observe? Diffraction. Wait a minute, huh? We can observe a diffraction, and that diffraction, with the diffraction we can know very well, as in our previous class we have seen how our electron diffraction is taking place onto a photographic plate, and that photographic on and onto that photographic plate, whatever the changes we have been recorded, and that changes which we are recording onto the photographic plate, that type of changes we are going to in this one, we are going to calculate the changes by using this viral method, or you can say this as viral equation, viral or viral. With your conveniency, you can pronounce it. What it is viral or viral equation. Okay, so once you are clear with this viral equation or viral method, then next thing in from our syllabus we want to learn in this equation is what about this equation tells us. What about this equation tells us? So its answer will be, this equation is giving rise to the formation, or this equation gives us an information which is regarding simply measuring angle, or you can say that is as scattering angle. That is as what? Scattering angle. Scattering angle and the scattering intensity. Now, you may ask me, ma'am, what is scattering angle and what is the scattering intensity? Okay, to explain this scattering angle and this scattering intensity, first of all, you must have to know how our diffraction pattern takes place. So, each and everybody is very well known with the diffraction pattern, which is about electron diffraction, which we have been learned in our previous class. And if you are not aware, or if you have not completed the previous one class, I would like to request everyone, that is, go in my that previous class, go on my Google Classroom and take your second class of electron diffraction and complete that measurement technique firstly, and then only come towards the viral equation, or you can say that is this viral equation, and then only you can know that simply scattering angle and the scattering intensity. Now, whatever our equation, that is this diffraction equation is there, or diffraction pattern is there, this diffraction pattern gives you simply angle of diffraction, that I'll be showing you by using a diagram. Wait a minute till I'm drawing a diagram here. Please do let me know, is it visible to you? See, this is the sample, for example, and onto this sample your electron beams are bombarded, and when these electron beams are bombarded onto our sample, then what happens? There is a coherent phenomena takes place, and that coherent phenomena is giving rise to the formation of a diffraction. What it is giving us? It is giving us an information regarding a diffraction. Now, and you may ask me, ma'am, how we can know, or how calculate this diffraction? So you can calculate this diffraction pattern by you. Whatever these rays are coming, na, these rays are falling onto this sample, and whatever this sample is there, this these samples, whatever these your rays are there, these rays are getting scattered, these rays are getting diverted, or you can say that rays can be passed through the sample, and once they coming out of your sample, that they get in this form, and this what we can say, that is this pattern, this all this pattern, all this one pattern, where your lights are getting where your lights are get coming out of your sample, that is known as a scattering, that can be known as a scattering, and that scattering is giving rise to the formation of a diffraction pattern. It is giving rise to the formation for a diffraction of your sample. It is giving rise to the formation of for a your diffraction pattern. And now whatever this diffraction pattern you are noting, you are measuring, that diffraction pattern you can give by using a photographic plate, and that photographic plate, onto that photographic plate, whatever the scattering angle and scattering intensity, whatever the scattering angle and scattering angle and the scattering intensity is there, that two criteria are getting recorded, and that criteria you can record by using simply a graph, by using simply a graph. Now, as I told you in my previous class about your photographic plate, about your this measurement technique, it tells us complete information regarding scattering angle and the scattering intensity. So how we can know, how we can confirm that? So that, as I told you, that photographic plate gives us an information which is regarding, gives us an information which is regarding this angle and this intensity, और this angle and this intensity मतलब ये जो आपके रेज है उनकी इंटेंसिटी क्या होती है, उन रेज की इंटेंसिटी और उन रेज की जो कुछ भी इंटेंसिटी और एंगल होता है वो हमें मेजर करना है, वो हमें just wait for a minute. Am I audible? Hello, am I audible?
Yes, ma'am.
यस मैम.
Yes, ma'am.
क्लियर है ना आवाज?
हाँ क्लियर है.
Okay. So where I was on scattering angle and the scattering intensity. लक्षात तर येत आहे ना सर्वांना? Okay. So whatever the scattering angle and the scattering intensity is there, in these in these intensities and these scattering angles, whatever the relation is there, that relation we can plot onto a graph. We can plot them on a graph, and that plotted graph can tells us information which is about whatever the scattering angle is there, that scattering is increasing, that is scattering angle as it is increasing with decrease in the scattering intensity. देखिए इस ग्राफ से आपको पता चलेगा, देखो क्या पता चलेगा आपको, ये जो ग्राफ मिल रहा है आपको, तो वो ग्राफ कैसे मिल रहा है, देखिए आपको यहाँ पर इस ग्राफ में मैंने दिया है, जिसको मैं और एक बार से प्लॉट करके बताती हूँ आपको। तो क्या दिया है हमें इस ग्राफ में, मैंने आपको scattering intensity versus scattering angle. So scattering angle is denoted by the notation theta. What it is? Theta. And scattering intensity is given by the equation or given by the notation I. Intensity I. Okay. Then after, when scattering angle and scattering intensity's relation is there, when your scattering angle is increasing, it is increasing with increasing scattering angle, it with decrease in scattering, it will be decrease in scattering intensity. मतलब जैसे जैसे आप देखिए x एक्सिस की तरफ आपके जैसे जैसे एंगल बढ़ रहा है, वैसे वैसे आपकी इंटेंसिटी क्या होते जा रही है, वो डिक्रीज डिक्रीज होते होते जा रही है या फिर इंक्रीज होते जा रही है, वो ऑब्वियसली आप ऑब्जर्व कर सकते हो। वो कम कम, पहले देखिए ज्यादा थी, फिर थोड़ी कम 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 होते गई है। एंड ये जो कुछ भी आपके ग्राफ का नेचर है, दैट इज विथ इंक्रीज इन स्कैटरिंग एंगल, योर स्कैटरिंग इंटेंसिटी इज गेटिंग decreased, it is getting decreased. And whatever the scattering angle and scattering intensity phenomena is there, these phenomena, let me just erase this. So, in the scattering angle and the scattering intensity phenomena, whatever the scattering angle and the scattering intensity, wait a minute, huh? I think screen is visible to everyone. Is it?
Yes, ma'am.
Okay, thank you. So, whatever this scattering angle and the scattering intensity is there, that okay. You should ask me one question, ma'am. Whatever our scattering angle is there, that scattering angle and scattering intensity, if you're calling that is as, if you're calling that is as, it is getting decrease. But there is no steady decrease in our scattering intensity and the scattering angle. Steady decrease हो रहा था क्या वहां पर? बिल्कुल भी नहीं। अगर डिक्रीज हम बोल रहे हैं, मतलब क्या होना चाहिए था? ऐसा डिक्रीज होना चाहिए था। बट वो ऐसा डिक्रीज हो रहा था क्या? बिल्कुल भी नहीं। तो अब जब कभी भी ऐसा डिक्रीज नहीं हो रहा है, तब उसको हम क्या बोलते हैं? इट इज नॉट हैविंग एनी मीन्स इट इज नॉट हैविंग स्टेडी डिक्रीज इन योर स्टेडी डिक्रीज इन योर इंटेंसिटी with respect to the increase in angle, with respect to increasing your scattering angle. तो अब इसको एक्सप्लेन करने के लिए हम कैसे बोल सकते हैं? इट शोज मतलब स्कैटरिंग इंटेंसिटी इज डिनोटेड बाय आई एंड स्कैटरिंग, हेलो हेलो हेलो, व्हाट हैपेंड? ऑडियो वीडियो इज क्लियर? Is my audio
Yes,
and
ma'am.
video is clear? Screen is visible to everyone?
Yes, madam.
Okay, okay. And please try to mute your phones. Phone. I was on scattering intensity and scattering angle. So these maximas and these minimas, this is a maxima for your intensities and with respect to change in your angle. And these are the some maximas and these are the some minimas which are included in our scattering angle and scattering intensity graph. And then after, ये जो कुछ भी अब मैक्सिमाज एंड मिनिमाज आपको मिलते हैं ना वायरल इक्वेशन में, so these maximas and these minimas, by through this differentiation, as I told you in previous class, and as I am telling you again and again, why? Because I'm telling you, because its the reason is quite simple. That is, ma'am, you should not ask me. That is, ma'am, how can we calculate that electron diffraction pattern, or how can we calculate that our, or what is the importance of electron diffraction, or what is the how we can know or how we can get the graphical representation of our photographic plate, or that photographic plate, or you can say that is as graphical representation. So it's an all these question answer is only one, and that is simply by using viral equation. By using this viral equation, you can know or you can calculate the internal dynamics or internal structures. What I told you, what can we calculate in electron diffraction? We can calculate in electron diffraction. We can calculate in our electron diffraction, that is D. That is what? D. And what is that D? That D is nothing but the interplanar space, interplanar spacing. What is that D? D तुम्हाला माहिती आहे, XRD मध्ये, सॉलिड स्टेट मध्ये, 11th 12th ला तुम्ही 12वीला तुम्ही सॉलिड स्टेट शिकला, तिथे डी म्हणजे काय होतं. परत बीएससी फर्स्ट इयरला ब्रॅग्स इक्वेशन शिकलाय तुम्ही तिथे. अँड ऑल्सो इन एमएससी फर्स्ट इयर यू स्टडीड युअर ब्रॅग्स इक्वेशन in solid state as well as in our XRD topic. So what is that Bragg's equation, or what it tells us? It tells us an information regarding D. And what is the D? D is interplanar spacing. What is that D beta? Interplanar spacing. And that interplanar spacing मतलब आपके जो क्या बोलते हैं हम एटम्स होते हैं, या फिर जो कुछ भी दो एटम्स में जो कुछ भी स्पेसिंग होती है, वो स्पेसिंग इज डिनोटेड बाय डी. एंड दिस ओहो ओके, नो मेसेज पण दिसतोय का तुम्हाला? हॅलो.
हाँ मैम.
दिसत मॅम.
ओके ओके, लेट मी जस्ट क्लिअर इट. होतच नाहीये काही, का असं होतंय?
करा ना मॅम, ते कॅन्सल.
अरे होतच नाहीये, ते क्लिकच होत नाही, हँग झाला वाटतं मोबाईल. अरे थांब, मी स्क्रीन कॅन्सल करून बघ. येस, तुम्हाला स्क्रीन दिसतीये ना?
हो मॅम, ती नोटिफिकेशन पण दिसली ना.
हो
दिसली ना? बरं ठीक आहे. ओके, आय थिंक आता आता फक्त तुम्हाला स्क्रीन दिसत असेल, राईट?
हा दिसली.
यस यस.
ओके, इट शुड बी क्लिअर ना. याला ड्रॅग करता येत नाही. ओके, लेट मी जस्ट स्विच इट. हा, जसं मी म्हटलं तुम्हाला आताच की इंटर ॲटॉमिक जे काही डिस्टन्सेस असतात, म्हणजे कसं बघा, समजा तुमच्या ॲटम मध्ये समजा इथे तुमचे हे एक दोन लाईन्स आहेत. ओके, इथे एक ॲटम आहे तुमचा आणि इथे एक ॲटम आहे. अँड द डिस्टन्स बिटवीन दीज टू ॲटम्स ना, दिस कॅन बी नोन ॲज इंटरप्लेनार स्पेसिंग, दॅट इज एज डी. स्मॉल डी आहे, ते स्क्रीनच्या बाहेर जात आहे, मी इकडे काढते त्याला. स्मॉल डी, बोटांनी लिहिणं फार अवघड आहे बाबा. स्मॉल डी, आणि ते जे काही स्मॉल डी आहे, दॅट डी इज नथिंग बट द इंटर atomic distance, or in XRD we can name it as interplanar spacing. Interplanar spacing, both are one and the same. हा, फक्त तुम्हाला समजावं म्हणून त्याची वर्डिंग चेंज केलेली आहे. नाउ, and that can be given by Wierl equation. And what is that our Wierl equation? तेव्हापासून मॅम तुम्ही बडबड करता की Wierl equation किंवा viral equation. What is that? So most awaited point or most awaited equation is in front of you, and that is right here, and which is denoted by an arrow, and that is I of theta. It is not q, huh? It is theta, and theta is scattering angle, and I is what? Scattering intensity. What does it mean? तुम्ही म्हणाल मॅम ते तर ग्राफिकल तुम्ही वेगवेगळं दाखवलं दोन अँगल वरती, आणि इथे का दाखवता एकत्र? Why I am representing it here, both of those terms, it represent as the relation between intensity and your scattering angle, relation between your scattering angle and the scattering intensity, and that is equals to summation over ij of f of I, f of j, sin in, summation s r ij by srij. Now you may ask me, ma'am, what is the summation over ij means? summation over ij means here the atoms or the wave functions which you are taking here for your consideration, that for ith atom and that for the jth atom. काय काय atoms घेताय तुम्ही? I atom and the jth atom. तुम्ही कोणते कोणते atoms घेताय? I atom आणि J atom. सो आय आणि हे जे काही तुमचे ऍटम्स आहेत ना, तर हे आय आणि जे ऍटम्स मधले जे काही तुम्ही फंक्शन्स घेताय, दॅट फंक्शन्स दॅट इज लाईक fi and fj, that in another words or some other literature data which I will be showing you after some time. But before that, fi and fj, what is that? Fi and fj is known as fi and fj is known as your wave functions for that ith molecule and jth molecule, or you can say that is as for I molecules के लिए साई आई बोल सकते हो या फिर एफ आई दे सकते हो. कुछ कुछ लिटरेचर्स में उसको साई आई दिया है और साई जे दिया है, एफ जे जैसे मैंने लिखा है, तो वहां पर आपको कंफ्यूज नहीं होना है. और उनमें की जो एंगल है वो साइन ऑफ एस आर आई जे एंड साइन डिवाइडेड बाय एस आर आई जे, and this is nothing but the very famous one equation, and this equation is known as Wierl equation or Wierl equation. With your convenience, as I told you, pronounce it, call it. Okay, so with this, can you please tell me, are you guys clear with which I just did the blah 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 discussion? Oh shit. Save. ओके, सांगा मला अगोदर इथपर्यंत समजलं का? का काही नाही समजलं? आर यू गाइस देयर?
इक्वेशन जी आहे ना ती थोडं रिपीट कराल का?
Okay, no problem with it. I'll be. See, Wierl equation explains you information or the terms which are there in our Wierl equation are there. See, इथे तुम्हाला दिसत असेल बघा आता. In Wierl equation, we can have the equations or we can have the terms like theta. Theta is what? Scattering angle. The I is what? Scattering intensity. Then after, F is what? Electron. F is what? F is what here? Electron scattering factor. F is what, beta? Electron scattering factor. Are you guys clear with this annotation?
Yes, ma'am.
As I told you, theta is what? Scattering angle. I is what? Scattering intensity. And F is what? Electron scattering factor. Are you guys clear? F is what? Electron scattering factor. मतलब electrons कितने scatter हो रहे हैं उसका factor देने के लिए जो notation हम use करते हैं उसको बोलते हैं F. और that for I molecule and for J molecule and for J molecule, that for I and the J molecule. And what are they? They are represented by the notations F of I and F of J. And as I told you just now, that Fi and Fj can be represented by the psi I and psi j. As Kondar ma'am have been told you already, simply whatever this psi I and psi j are there, these are nothing but the wave function. These are nothing but the two different wave functions. These are nothing but the two different wave functions, and these two different wave functions gives you information which is regarding your atoms. And then after, sin SRIJ and sin SRIJ. What are these? these are nothing but the angles and the intensities of your these ith and jth molecule. मतलब उनमें जो angle होगा वो angle and divided by SRIJ, that is nothing but your simply S. That S term is what? Now you may ask me, ma'am, what is this S term? Is there any importance of this? Yes, or is there any explanation for this S term? So its answer is yes. In that answer is right here in front of you. And what is that? Just let me show you. And that is this one. What is that? Where S is equals to, where S is equals to 4 pi by lambda sine half theta. Sine half theta. What is that S beta? S is equals to 4 pi by lambda sine 1 by 2 theta. And when you put these equations, when you put this equation into above side equation, this viral equation, then you can get, or you can compare just the interatomic distances और इंटर जो कुछ भी आपको ये इंटर एटॉमिक डिस्टेंसेस मिलेंगे, इन इंटर एटॉमिक डिस्टेंसेस पर से आप लोग बता पाओगे, ग्राफ पर से आप लोग बता सकते हो कि आपके स्ट्रक्चर मतलब आपको जो कॉम्प्लेक्स बोलो या फिर मॉलिक्यूल बोलो, सो दैट कॉम्प्लेक्स और that complex or that structure, that complex or that molecules structure you can represent by using this interplanar spacing or by using this interplanar distance, and that structure can be determined by using simply this Wierl equation, and that is that is cis or trans. Very simply or very easily you can explain it by using your cis and the trans structures. Means what? Means, as I told you again, that is with the help of electron diffraction. With the help of our electron diffraction, we can determine internal dynamics, or you can say that is as, in another words, internal structure of our molecules or our complexes, and that is by using your and that is by what for? That is for your complex is cis, or that is as for your complex is trans, and that we will be learning in our next class. But before that, please tell me, is up to this, is everything is clear? Yes or no?
Yes, ma'am.
Okay, everything is clear and audible थी मैं पूरी क्लास में?
हाँ, ma'am.
If you have any
Yes,
doubt,
ma'am.
you are, yes, you are open to ask if you have any doubt. Is there anything? Is there anything? Hello?
No, ma'am.
So I'm considering from your side that everything is clear to you.
Yes, ma'am.